Hello guys, good day to you and welcome to our class for today. Alright, so for this class we'll be looking at electromagnets and then their application. Okay, we'll be looking at electromagnets and their application. So please get your writing materials ready so that we can go to our class for today. It's going to be a very short lecture, a brief one, and I just want you to pay attention as the lecture progresses. Please, if you have not subscribed to our channel, especially if you are if you are just visiting this channel, please subscribe, give us a thumbs up, give us a like, and then also give us a positive comment. All right, also click on the notification bell so that whenever we upload a new video, YouTube will notify you. This is Noble Mind Science Just Online, and we are your online physics tutors. Okay, so you can also reach us through the WhatsApp link that is under this video or the number that is showing right on your screen. Alright, so please, if you are ready, let's go to our class for today. Alright, so as I said, we are looking at electromagnets. What are electromagnets? Okay, so this picture depicts a typical electromagnet. Alright, so if you look at the electromagnet, it is made up of a U-shaped iron core. Then you have wires, okay, around it. Then it is connected to a battery and then to a rheostat. Okay, so an electromagnet is a soft iron core in a current carrying solenoid. Alright, so this is solenoid. The magnetic field of the coil induces magnetism in the soft iron, which produces a powerful magnet with a strong magnetic field. So this is the soft iron core, then this is the solenoid in which it is inserted. So when current flows in here, it makes it to become, it produces a strong magnet, a strong magnet with a strong magnetic field. So this can be fed by the attraction of this iron plate that is here. Okay, so an electromagnet can be made by winding coils of wire on a soft iron in opposite direction around the two arms of a U-shaped soft iron bar. Alright, so when current flows around the solenoid, around the iron windings, a strong magnetic field is produced. Now the strength of the electromagnets or of the magnetic field produced depends on one, the quantity of current that is allowed to flow in through this rheostat, the increase in number of turns of wire in the coil. So the more turns of wire on the coil, the stronger the magnet that is produced. Then a high permeability core, so a very good iron core, we make this magnetic field to be very strong. Okay, so those are the factors that determine the strength of the magnetic field produced. Then the uses of this electromagnet, one of them is the intense magnetic field produced are used in electric motors and generators. So if you check your generator motors, you see that the rotating motor is made up of electromagnets. They are also used in lifting heavy pieces of iron and steel, especially if you go to ports where they have to arrange cars in different places. They use this principle of electromagnet to carry the cars. A large magnet will pick the car, a large magnet will pick the car and position it in another location. Okay, they are also used in electric bells, telephone earpiece. They are used in separating magnetic substance from non-magnetic substances. They are used in hospital to remove splinter of iron or steel from the eye. So these are some of the uses of electromagnets. Okay, so it's good that you take note of this. So now we're going to look at applications in electric bells and telephone earpiece. So the electromagnet is used in the electric bell. So if you look at the diagram of the electric bell, this is the electromagnet. Alright, so this is your U-shaped magnet, and this is your solenoid, and then This is your hammer, the armature. This is a spring that controls the movement of the armature when current is applied or when the bell switch is depressed. Then this is your gong. All right. So this is your electromagnet, and then this is your battery. So the electric bell consists of a U-shaped magnet with a coil of wire worn in opposite direction. Okay. So the coil of wire worn in opposite direction on an iron core forms the electromagnet. So what is the working principle of the electric bell? These are mostly questions that they give to you in theory, physics theory. So when the bell switch is pressed, current flows through the coil of the electromagnet and the soft iron armature is attracted. Once current flows through, this iron core becomes a magnet. Okay, so it will now attract this armature, and then the hammer will now, this hammer will move so that we strike the gong. Once it moves and it strikes the gong, it will now produce a sound. The movement of this armature breaks the circuit because this is the point at which the circuit is completed. So it will break the circuit. Once this armature moves in this direction, it will break the circuit. And then when it breaks the circuit and the current is cut off, the electromagnet will lose its magnetism and the armature is pulled back by the spring. Okay, once it is pulled back, the circuit is now completed again and current will flow. The process is repeated, and this continuous repetition of the process will make you to be hearing the sound continuously. Alright, so that is the working principle of the electric bell. Okay, so if you can be able to draw this and you are able to explain a little of it, you are okay, but it is good that you understand what happens. So the electric bell works with the principle of electromagnetism. Another instrument that works with this principle of electromagnetism is the telephone earpiece. Okay, so this is a picture of a telephone earpiece. This is another picture of it. So here you have the electromagnet. So an electromagnet consists of a bar magnet placed between the two soft iron pool pieces with solenoids wound in opposite direction. That's what you have here. Okay, then you have a thin magnetic alloy diaphragm. This is the diaphragm. This diaphragm bounces to and fro as sound is being produced. It bounces to and fro. The diaphragm is attracted to the pole piece by the magnet bar. Okay, so for the diaphragm to move to and fro, it has to be attracted by this electromagnet. Then this is direction of current flow. So what is the working principle of this piece of equipment? When a person speaks into the microphone at the other end of the line, a varying electric current is set up having the same frequency as the sound waves. A similar current passes through the solenoid in the earpiece. Okay, so the sound wave from the other mouthpiece of a microphone, we set up varying electric currents, okay, with the same frequency as the sound waves. So when you speak into your microphone, that sound that comes from your mouth sets up a varying electric current on the earpiece of the other person that is listening to you, and then a similar current passes through the solenoid in the earpiece. This alters the strength of the magnetic flux in the U-shaped magnet, producing a corresponding vibration, a corresponding variation in the pull of the diaphragm. Okay, so this later vibrates, the diaphragm will later vibrate and reproduces a copy of the sound waves which enters the microphone initially. Alright, so that is the working principle of the telephone earpiece. Okay, so that is it, and then these are the applications of electromagnetic principle, well, or the application of the electromagnets. Okay guys, so I think this is where we end this particular class. As I said, it's a brief one, and I don't want to waste much of your time. So just know the working of the electric bell and then the telephone earpiece and then the application of electromagnets. Okay, so thank you so much for your time. But before I leave, please subscribe to our channel, give us a like, give us a comment, give us a positive comment, click on the notification bell so that when we upload new videos, YouTube will notify you. Thank you so much for your time. We really appreciate you being with us for all this while. Invite your friends so that they can come and enjoy what you are enjoying. This is Noble Mind Science Tutors Online, and I remain your physics online tutor. Reach us through the WhatsApp number that is showing on your screen or through the link, the WhatsApp link that is down on this video. Thank you, and good to see you in our next class. Have a nice day.